Hi everyone, this is Mr. Chu bringing you a video to help you with exercise 2D, question 7 and question 8 from the work program in our topic covering algebra. In this video, I'm going to cover two important formulas. The first one is called the difference of squares formula. And I'm also going to cover two formulas which are called the perfect square formulas. I'm going to show you where these formulas come from and also go through some examples of how we can use these formulas to expand brackets. Now, as I go through this video, I encourage you to take notes and put them in your bound reference. If you miss anything, by the time you watch this video, these notes will be available on Teams. So don't worry, if you miss something, you can always go back and look at it later. So let's get underway. You will remember that to expand brackets, I often drew arrows to indicate where multiplication is taking place. When I've got two brackets written like this, next to each other with two terms, I'm going to have 4 multiplications happening. So if I expand this bracket, I'm going to get a times a plus a times negative b, that's the top 2 arrows, plus b times a plus b times negative b. These are the bottom 2 arrows. Now, using your knowledge of indices and simplifying expressions from exercise 2c, we can rewrite this as a squared minus ab plus ba minus b squared. And at this point, we know that b times a is the same as a times b. In other words, ba equals ab. So I can rewrite this term as ab. So I'll go ahead and do that. A squared minus ab plus ab minus b squared. You'll notice I have ab minus and ab plus. These two terms are going to cancel to 0. And so I am left with, after simplifying, a squared minus b squared. Now, instead of expanding the brackets every single time and going through all this algebra, because this comes up so frequently, we're going to give this a name. We're going to call this the difference of squares formula. And wherever you see a plus b, a minus b, or equivalent, we are going to deploy this formula. And the reason why it's called the difference of squares is because I've got two squares, a squared and b squared, and when I subtract or minus, that's the difference. It literally is a difference of 2 squares. So keep this formula in mind, because now we're going to use it to expand some brackets. For example, let's take this one, p plus q times p minus q. If I know that a plus b in brackets times a minus b in brackets gives me a squared minus b squared, when I expand p plus q times p minus q, I'm going to have the first number squared, it's giving me p squared, and then the second number q squared. And I'm taking the difference. So all I've done here is I have replaced p with a and Q with B. All right, let's look at this one. X plus 4, x minus 4. Again, we have the same form as this, a plus b, a minus b. This time, x is a, and 4 is b. So this time, I'm not going to have two letters squared. I'll just have one letter, x, squared, and I'm going to have 4 squared. And then I take the difference. Now, we can rewrite 4 squared as 16. Remember, when I square a number, that's the same as multiplying the number by itself. 4 times 4 gives me 16. And so, when you're asked to expand brackets, I would like you to write this second step where you evaluate the number squared. All right, let's look at the next one. Y plus 9, y minus 9. This time I'm going to have y squared and 9 squared, and I take the difference. Now 9 squared is 9 times 9, which gives me 81. So my final answer when expanding brackets will be y squared minus 81. All right, let's do the next one. 12 plus z times 12 minus z. This is going to give me 12 squared minus z squared. Notice that the 12 came first because in my brackets, 12 is the first number. So I've got to be consistent with the way I position my numbers. Now, 12 squared is the same as 12 times 12, which is 144. So I can rewrite this as 144 minus z squared. And the last one, down the bottom, 8x plus 10y, 8x minus 10y. This one is not so obvious. So what I'm going to do is I'm going to show you how to do this. Just draw a line here. Okay. My first term is 8x. So I can't just square the 8. I have to square the entire term 8x. So it's going to look like this. 8x and the whole thing squared minus the second term. Here I've got 10y replacing b. So I've got to take the whole thing, 10y, and square it. So my first line is going to be 8x in brackets all squared minus 10y in brackets all squared. And at this point, we need to use our index laws. So index law, I believe this was number 4. If I have two numbers multiplied by each other to the power of n, that's the same as the first number to the power of n times the second number to the power of n. So this is going to give me 8 squared x squared minus 10 squared y squared. Notice that I've applied the power of 2 to both the coefficient and the pronumeral. And I would like you to simplify 8 squared and 10 squared. Give me a single number without indices. So here we need to know that 8 times 8 is 64, and 10 times 10 is 100. So this gives me 64x squared minus 100y squared. And this is what I would like you to write on a test. So that will take care of question 7 in exercise 2D. Now I'm going to show you two more formulas. And this one is probably new. If you were in my Year 9 class last year, I did this very, very quickly. This year we get to spend a little bit more time on it. So what we want to do is expand a plus b in brackets all squared. And if you're seeing this for the first time, it's not obvious what to do. I'll give you a hint. The answer is not a squared plus b squared. It's a very common error that students make. It's not this. And let me show you why. Remember, when I square a number, that means multiplying the number by itself. So this is actually the same as a plus b multiplied by a plus b. So I just have the same thing repeated twice. And now, because this is the first time we're looking at this, we will do the expansion. So this is going to give me a times a plus a times b. And then I've got to do the other two as well. B times a and b times b. And this is going to give me a squared plus ab plus ba plus b squared. But we know that ab and ba are the same. When I multiply two numbers, the order doesn't matter. So I can rewrite this as a squared plus ab plus ab plus b squared. And we also know that if I add ab to itself, I get 2ab. So this is my final result. A squared plus 2ab plus b squared. Note that we get this extra term in the middle, 2ab, in addition to a squared plus b squared. So, just like before, instead of doing this expansion every time, because this comes up so often, I'm going to give this formula a name. I'm going to call it a perfect square. And every time we see the left-hand side, we know the right-hand side because we have access to this formula. Now, we can do something similar with a minus b, and I will leave this to you to do as an exercise. I want you to show that this, with a minus sign, is the same as a squared minus 2ab plus b squared. To show this result, you'll need to be careful with negative signs, but for the purposes of doing question 8 in the work program, you can just take this formula and use it. Okay, so these are two new results. I think they'll be new for most of you, unless you've spent a lot of time doing algebra in Year 9. So let's do the same thing. Let's take these formulas and use them to expand expressions involving brackets. So here are the formulas again in purple. They're there for you. So the first one is x plus y all squared. I'll just move this 2 over so that it's a bit closer to the bracket. That's better. So what should we do? Well, you should see here I have replaced I've replaced a with x, and I've replaced b. Sorry, I'm using this formula up here. So I'm replacing a with x and b with y. So I'm going to have x squared plus 2xy plus y squared. All I have done is replace a with x and b with y. That's all I've done. Okay? There is nothing else we can do because x squared, y squared, and 2xy are all different terms. I cannot add them together. So that's done. You have nothing else to write here. Now, before we continue, I want to remind you that 2ab means 2 times a times b. That's going to be important once the letter b becomes a number, like it is in this second example. So this time, I'm going to have x squared plus 2, and this time I'm going to write it out like this. A is x, so it's 2 times x, and b is now 4. So it's 2 times x times 4 in the middle, plus y squared. And we can simplify. 2 times x times 4 is the same as 2 times 4 times x. 2 times 4 gives me 8, and 8 times x is just written as 8x. So this is going to become x squared plus 8x. Sorry, that should be a 4, not a y. 4 squared is 4 times 4, which is 16. So I want you to notice, here I started with 4, and then I doubled it. Because I have the number 2 in my formula. So my middle term is 2 times x times 4, giving me 8x. All right, let's do another one. This time, instead of 4, I've got 8. So a is x. This time, b is the number 8. So when I expand this, I'm going to get x squared plus 2 times a times b, where a is x and b is 8. So it's going to be 2 times x times 8 plus the second number squared. So 8 squared. 2 times 8 gives me 16. 16 times x gives me 16x. And 8 squared is 8 times 8, which gives me 64. Notice 2 times x times 8 gives me 16x. So if I have just one x here and a number here, the number appearing in the middle with the letter should be double the number that I have in the brackets. So I've gone from 8 to 16. Here I've gone from 4 to 8. If your number is not doubled, then you've done something wrong. Check how you've applied the formula. Okay, 2 more examples. This time, it's a minus, so I'm going to use the second formula now. My first number, a, is y. My second number, b, is 8. And all I'm going to do is put this into the formula. Wherever I see a, I'll put y. Wherever I see b, I'll put 8. So this is going to be y squared minus 2 times y times 8. Notice b is positive 8. So I don't need another minus sign here. Plus 8 squared. b is positive 8. I don't need a negative sign here. Okay, this becomes y squared minus 2 times 8, which gives me 16. 16 times y gives me 16y. Notice again, 16 is double 8. I'm expecting this to happen because I've got a 2 in this formula. And 8 squared is 64. So year 10s, I want you to notice the only difference between these two formulas is actually here, in the plus and the minus sign. The a squared and b squared on the left and right, they stay the same. So maybe you only need one formula, but in reality, most people remember both, and that's fine. Okay, last one. It's the same idea. So this time, a is going to be 3x, and b is going to be 7y. Wherever I see a, I'll put 3x. Wherever I see b, I'll put 7y. I'm just going to write this a bit more carefully. So this equals 3x all squared, because I've got to square the whole thing in yellow, minus 2 times 3x times 7y plus 7y all squared. And here we have to use index law number 4 again. So this is going to become 3 squared x squared minus 2 times 3 times 7. That gives me 6 times 7, which is 42. X times y gives me xy. So my middle term is 42xy plus 7 squared y squared. Again, applying index law number 4 when squaring an expression in brackets. And I would like you to go one step further and evaluate 3 squared and 7 squared. 3 squared is 3 times 3, which is 9. 7 squared is 7 times 7, which gives me 49. Now, let's take a look at this number in the middle here, 42. It's not double 7 anymore because the number in front of x is no longer 1. However, 3 times 7 gives me 21. And if I double that, 21 times 2 gives me 42. So I should still have this doubling thing happening for the middle term. And that's a good way to check that you have done this calculation correctly. I guarantee that if you make a mistake on this, it's usually to do with these middle terms when expanding the brackets. So just be careful and look out for that. Okay, so that's it from me. Your goal is to try to get as much of exercise 2D done today as you can. We are going to move on from this next week and start on factorizing. So anything that's not done today becomes homework. So hopefully that's an incentive for you to make productive use of today's class. If you've been away, I am happy for you to start on 2D and skip 2C. But take a quick look at the questions and see which you are more comfortable with. If you're more comfortable with 2C, then start with that first. If you haven't got a maths teacher with you, then feel free to discuss amongst yourselves, but obviously make sure that everyone has a chance to get some work done as well. Nobody in this class has messaged me on Teams yet, so I look forward to hearing from you when you do have a question. And if I still don't get any questions, then maybe I will offer some treats for the people who do get in touch, just as an incentive. All right, so I hope you have a good class. Please make the best possible use of it, and I look forward to seeing you all next week. Bye.